one little sum, so it's going to be like 5 minutes long, but it's all about geometry. So in this geometry sum, have we done all the geometry this year? Yeah. But I'm for sure certain that you haven't practiced enough.
Yes, ma'am.
And there's still things that I can teach you as we go along. This is the reason why every so often, every week, you're going to have one or two of these riders or one of these proofs to go and do. So, is it a proof of a theorem? No, it's a proof of a sum. Questions all differ from each other. This question said, O was the center of the circle. They will always do that so that you don't have to worry. This looked like it was a tangent, and they did say it. You don't guess. It doesn't have to look like it has to be. Okay, looks can be deceiving. ST was a tangent. So the moment that they tell me it's a tangent, I take my highlighter pen and I make sure I can see it's a tangent. Because immediately, 3 theorems jump out at me. Which 3 theorems? 7, 8, and 9. You with me? You must know your 9 theorems. That's the way that you do these sums. So when I want to look at this question and I know that it's a tangent, I can immediately go, and I always think theorem 9 first, for some reason. Can I look at theorem 9 and do something here? Because then what's theorem 9? Tan chord, tangent, chord. Take your fingers to the chord, so it's formed by KT. Then you've got to go to the circumference. There's your side, opposite side, but not O, because that's not on the circumference. To L. So this would mean that L would be 36. Okay? Tan chord theorem. But what else about the tangents? The radius will be perpendicular, not 45, 45. This one is 36. So what's left there? 54. And that was my first question. T2 is equal to 54, just like that. What about all the theorems there? That's what you've got to tell me now. Why is it 54? Because the tangent is perpendicular to the radius. That's what your 2 marks will be there for. That was allocated there. Okay, now we've done it all. And right, guys, remember you can do things on different ways. Some went from A to B to C, from A to C, then B, and so that's fine, but it's got to look logical. Okay, what else about the tangents? Was the part yet? No part yet. Are you with me?
Yes, ma'am.
What else?
We have a data.
Bow tie? Bow tie has to have all 4 points on the circle circumference. This one's not there. What is this? An angle at the center. Is 2 times the angle at the circumference. So this label here will be 72. But can you turn your head like this? So you can see the angle at the circumference and the angle at the center both coming from KT. To the center, to the circumference. So angle at the center is twice the angle at the circumference, meaning this is 72. Don't make it 18, okay? It's not half, it's double. And that was also asked angle O over here. So first of all, they did ask me for L. I did find L is equal to T1, which was for 36. And the reason? Tan chord theorem. Mark, 2 marks again. KOT we've done now. KOT would be 72 because it's double angle L. Reason? Angle at the center is 2 times the angle at the circumference. Again 2 marks. Last question on it was 3 marks. Prove to me with reasons that Km and ML would be the same. Now we've done a lot of the theorem 7, 8, and 9 with the radiuses, we check them out. Of the tangents, we check them out. But what about the rest? Which theorem are they looking for when they want to prove Km equal to ML? Km, ML. Is it a diameter? It's going to go through the center to be a diameter. Yes? Line from the center?
Perpendicular.
But it's not. And if it was, would that be true? What does the theorem look like?
Oh yeah, it would.
If it was 90, then this would be the same. That's what they're looking for. But I don't have 90, or do I?
You don't know.
I do. If I look, what's this little angle there squished in there in the middle? What's this going to be? That's 72. So what's left there?
Oh yeah.
18. 72 is 90. So that will be 90.
Wow.
And if it is 90, then those two little pieces will be equal. But they were urging you in that direction. If you want to prove something like that, it's got to be theorem 1. Either it's perpendicular and you can prove it's equal, or it's equal and you can prove perpendicular. But none of the two were given. Unless you went and worked out a few things like the 72, then you could find that 18 wasn't given for nothing. With that 18 and the 72, that angle M, and let's call it M1, that angle M1 would be? M1 would be 90 degrees, am I reason? Interior angles of a triangle. You can even say triangle KMO to make sure that they understand where you are. And if M1 is there 90, then the theorem is there. That would mean that Km would be equal to ML. Will I give you a mark for this? No, because that's what I'm asking. There'll be a mark for knowing that, and then because of that, line. Why is that equal to each other? Line from the center. Center of a circle. Is it perpendicular? It is perpendicular to a chord. Will bisect the chord. If it's perpendicular, it will do this. If it's bisected, then this must be 90. Are you with me? You've got to have the right reason. You will not get the mark if there's line from the center to the center of a chord. That's not right. If it's perpendicular, it will be bisected. If it's bisected, it will be perpendicular. You've got to get the right question with the right answer. Okay, so next questions for next time in geometry.